Good day everyone! Do you know what is a freshwater generator? So a freshwater generator is a vital piece of the auxiliary machinery that produces a fresh water from seawater through the process of the distillation or the reverse osmosis process. Hi, I'm JD Janmarki and please stand by and see the working principle of the freshwater generator. So this is the freshwater generator and I may be providing the 3D animation of this freshwater generator since it is easy to be understood. So first, let's dive to its vital parts. So at the heart of this unit, we find the two vital heat exchangers. The bottom heat exchanger serves as the evaporator, which is holding its responsible for the initial stage of the distillation process. So at the top of it, we have the top heat exchanger or the condenser, a semi-cylindrical shell that covers only the bottom half of the tube stop. This is designed to allow water vapor to come and to go in contact with the outside of the cold tubes, facilitating condensation. Here we have the deflector, which is responsible for changing the directional flow of the vapor to eliminate such moisture along with it. Next to that is we have the demister. So as the vapor progresses, the demister plays its role. This vital component is originally placed in the vapor flow to eliminate only mist that is carried with the vapor. Next is we have the safety valve, which is safety is of utmost importance. That's why safety valve is installed to safeguard against the overpressure. Next is we have the adductor. This is for maintaining the inside of the shell. It helps to sustain the required vacuum and also aids in removing the brine. This is the seawater feed inlet, and this is responsible for the feed water inlet valve that controls the flow of the incoming water. This is a distillate pump to extract the fresh water from the condenser. Next is we have the salinometer to test water salinity and also water being produced. So this is a three-way valve which allows the adaptable control over the water flow, allowing for efficient routing depending upon the salinity level. So a flow meter is installed to accurately measure the quantity of the fresh water generated. This is the hot jacket water inlet to the evaporator, which is an essential part of the process called distillation. This is the jacket water outlet, wherein the cold water exits the evaporator after the heat exchange process. So this is the cooling water outlet, where the cold water exits the condenser, having absorbed heat from the vapor and facilitated its condensation. We do have also the overboard valve of the ejector pump, which allows for the discharge of the water from the system after its usage. So this is the electrical panel, which is used to start the ejector and distillate pump. We also have the thermometers installed at the inlet and outlet of the jacket water, responsible for the temperature monitoring and control during the distillation process. And this is the pressure gauge at the discharge side of the distillate pump, responsible for the reading of the pressure at the pump's outlet, allowing for the performance of evaluations. So here's the step-by-step working principle of the freshwater generator. So first of the steps, we have the seawater intake. So the seawater is drawn from the ocean into the freshwater generator through the intake pipes located in the ship's hull. Next is we have the preheating. So the seawater is first preheated using the heat exchangers, which utilizes the waste heat from the ship's engines or other sources. So this preheating helps to reduce energy consumption during the subsequent evaporation process. So the third step is we have the low pressure evaporation. So the preheated seawater is pumped into the low pressure evaporator chamber, where it is further heated. So the chamber operates at lower pressure than the atmospheric pressure, reducing the boiling point of the seawater and facilitating the evaporation. So the fourth step is we have the boiling and vaporization. So as the seawater reaches its boiling point within the evaporator chamber, it vaporizes, turning into the steam. So the heat is continuously supplied the main boiling process, typically through the steam or hot water circulated within the evaporator. Next is we have the demisting or separation. So the steam generated during the evaporation carries small droplets of seawater with it. So the demister or separator removes these entrained droplets, ensuring that the vapor entering the condenser is predominantly pure water vapor. So sixth is we have the condensation. So the purified water vapor enters the condenser, where it is cooled by either seawater or air. So the cooling causes the vapor to condense back into the liquid form, forming fresh water. Next is we have the freshwater collection. So the condensed freshwater is collected and stored in the freshwater tank on board the vessel. So the tank may include level sensors and controls to maintain steady supply of the freshwater as needed. Next is we have the brine discharge. Any remaining brine or concentrated seawater which contains the separated salts and impurities is discharged from the evaporator. This brine discharge is typically regulated to ensure the compliance to the environmental regulations. So the last but not the least is we have the treatment and filtration. So the collected fresh water may undergo further treatment and filtration process to remove the remaining impurities such as sediment, bacteria, or dissolved minerals. This ensures that the fresh water meets quality standards for human consumption on board the vessel. So in conclusion, the freshwater generator operates through a series of controlled heating, evaporation, condensation, and separation process to produce potable water from the sea water, providing a vital resource of the crew and passengers of the vessel.